Welcome. Today we'll be looking at the Michaelis-Menten equation. So today I want to demystify make it simple in its simplest form. So before we do, this is the general equation for the Michaelis-Menten, this is the final equation form, which is V equals to Vmax at substrate concentration divided by the Km plus the substrate concentration. Now the V denotes velocity of the reaction. Or which is rate of reaction. Vmax is the velocity at which all the enzyme active sites are fully occupied. So further increase in substrate concentration will no longer affect the rate of the enzyme catalyzed reaction, where S is the substrate concentration of the reaction. Km is the Michaelis-Menten constant that describes the affinity of the enzyme to its substrate. So if the Km is high, the affinity is low. If the Km is low, the affinity is high. But before we derive the equation, there are steps that you must know. The first step is the basic reaction scheme of enzyme catalyzed reaction. So in this reaction scheme, we are assuming that the rate of the formation of ES is rapid, while the formation of enzyme plus of product is actually slow. Now the rates of the reaction, you can see the rate constant of this reaction, which is the K1, with the forward reaction where ES is produced. K minus 1 is the reverse reaction where ES is actually consumed, while K2 is the consumption of ES to produce the enzyme plus the product. Remember, we define enzyme as the biological catalyst that catalyze reaction, or that speed up the rate of chemical reaction or biological reaction without itself being consumed in the process of the reaction. So the first thing we do after defining this reaction scheme, we define the rate at which the product is formed. That is the first step. The rate at which P is formed. Rate at which P is formed is change in P over the T, which means this is rate of change of products with respect to time, and which is the dt. So this reaction is dependent on the concentration of the reactant. What is the reactant? ES, because ES is what is being consumed to produce the product. So we say K2, which is rate constant of that particular step, into bracket ES. So call this equation 1. Call this equation 1. Don't forget, I will still come back to this equation 1. The next step we produce, let me write back the equation or the reaction scheme. E plus S, fast reaction give ES, slow reaction to give E plus P. Now this is K1, this is K minus 1, K2. Now the second step is defining the rate of consumption and formation of ES, which is the steady state assumption. The assumption states that the rate at which ES is formed is also equal to the rate at which ES is being consumed. Now, based on that, let's give a mathematical illustration to that statement. The rate of ES with respect to time is equal to 0. So that means the rate at which ES is produced and which ES is consumed is equal to 0. So we'll go back to the equation and find out wherever ES is produced and wherever ES is consumed in the equation from K1, K minus 1, and K2. That is the first step to do. So on that note, so what we'll do, we'll go to equation 1, which is the K1. What happens to ES in K1? ES is produced. Its production is dependent on the concentration of the two reactants, which is the enzyme and the substrate. So we say K1, into brackets E into bracket S. Now, in K minus 1, ES is consumed. So when we say consumption, it means disappearance. So we use a negative sign, minus, bringing the constant, K minus 1. So the rate at which ES is consumed is also, in this case, ES is also the reactant or the substrate. It's also the reactant. So now we say its consumption is also dependent on its own concentration. So we say into bracket ES. Now in K2, ES is consumed. ES is consumed. And when we say ES is consumed, we say minus sign. So K2 into bracket ES equal to 0. Remember our definition. The rate of formation and the rate of consumption is equal to 0. So in this case, we'll look at the equation again. We have K1 into brackets S. Then in this case, we have minus. ES is common. ES is common here. So we'll pick one ES. ES. Then open a bracket. K minus 1 plus K2. So you can see equal to what? Equal to 0. So now if you look at the equation, if we multiply K ES times K minus 1, we'll get this. We'll get this. If we multiply ES times K2, we'll also get this one here. So now based on that, we'll say K1 ES. Then take the ES to the other side of the equation, which will now be equal to, the minus sign will now turn to plus. So we have ES bracket K minus 1 plus K2. We now have this. So the fourth step or the third step is to define the total enzyme in the system. Now recall that the total enzyme in the system, let's call this equation 2. Recall that the total enzyme in the system is equals to total enzyme equal to free enzyme plus bound enzyme. So there will be free enzyme and there will be bound enzyme. So when we do that, we'll now make the free enzyme the subject of formula. So we have free enzyme equal to total enzyme minus bound enzyme. That will give us call this equation 3. So substitute equation 3 into equation 2. We'll now have, remember, this is equation 2. We have K1 bracket E bracket, use a square bracket, S is equal to, we have ES equal to, ES brackets K minus 1 plus K2. Now, if we are including this, into the equation, we'll now have that total enzyme. We have K1 total enzyme. What do we have as total enzyme? Brackets. Let's say S. Let's say we have S K1S. They would interchange the total enzyme, the free enzyme, with total enzyme minus bound enzyme, which is equal to enzyme substrates bracket K1 plus K2. So what do we do now? We multiply into the bracket. So we have K1 S, then E total, right? And we have minus K1 S ES, which is multiplied by this. We have ES. So now what do we do from there? We take, well, we have ES K1 plus K2. So take ES to the other side of the equation. So we collect like terms. We have K1 S total enzyme equal to ES. Remember, we have into brackets K minus 1 plus K2, right? Plus K1 S ES. So now we have K1 S total enzyme. ES is common, so we have ES bracket K1, K minus 1 plus K2 plus K1 S. So dividing through by K1. Dividing through by K1, we have K1, K1, K1. So this cancel this. So now we have this cancel this. So we have total enzyme substrate concentration is equal to bound enzyme, which is ES. Then remember, K minus 1 plus K2 over K1 is equal to Km. So we'll convert everything here to Km plus substrate concentration. Now making substrate ES the subject of formula, we have ES is equal to total enzyme substrate concentration over Km plus substrate concentration. We'll now call this one equation 4. Remember, in our equation 1, we have defined equation 1, we have defined that the rate at which P is produced is dependent on the concentration of K2 enzyme substrate complex. So we will now take equation 4 to equation 1. Taking equation 4 to equation 1, remember, changing P over dt is equals to K2, open a bracket. We will now insert equation 4 into this. Remember, equation 4 is enzyme total S. Enzyme total S over Km plus substrate concentration, which is equal to K2 enzyme total, substrate concentration over Km plus substrate concentration. Now remember we say that the maximum velocity is at that point whereby increase in substrate concentration will no longer affect the enzyme activity. That means the enzyme is fully saturated. So when the enzyme is fully saturated, we say it has approached maximum velocity. So where K2 Vmax is equals to K2 total enzyme, which means all the enzyme is fully occupied. So with that substitute, we now have, remember, changing P over the T is velocity of a reaction, V, equal to K2ET is equal to what? Vmax. Vmax. Then substrate concentration over Km plus substrate concentration. That this is the Michaelis-Menten equation. So in our next video, I will teach us how to use the equation to solve problems involving inhibition, involving knowing the velocity of a reaction, knowing the maximum velocity of a reaction, knowing the Km of a reaction, and also how we can use the plot graphs to tell us the type of inhibition that is occurring in the enzyme inhibitor complex or enzyme substrate complex or enzyme catalyzed reaction. Do not forget to subscribe and follow for more videos on biochemistry. Thank you.